Hello. Today I would like to show you something that I'm not happy, something that I am ashamed of, but it's going to be a good example how you can go out from extremely bad situation just by thinking out of box. Over here on my desk I've got a gold Zero Yeti 400 that's got a problem with a broken inverter. This is the inverter board from the gold Zero Yeti 400. It is a broken inverter that I was trying to fix really hard. The problem was that the AC part stopped working. It indicated blown fuse, and as you can see, I replaced those two fuses. But after switching on, it was indicating that the inverter is starting, but showing a exclamation mark telling you there is no AC output. And yes, indeed, there was no AC output. I started doing diagnosis on that board. First thing that I found is that section is okay. It was creating high voltage around 400 volts. This is a separated part that is creating high voltage and is being stored in that capacitor around 400 volts. And the problem is with the H bridge, those 4 MOSFETs. They were all good, but sometimes they can fail at the high voltage, so the semiconductor tester might report them as okay, but they can fail at higher voltage. And I replaced 4 of them, but it still didn't work. Then I replaced the driver board. This is how the original driver board looks like. So I replaced it, but it still didn't work. I poke every semiconductor, every resistor, everything was looking okay, but the device still don't work. I tried to unsolder the smoothing capacitor. Maybe it was shorted, but it didn't. And I fail. After 2 months, I get into situation that the pads were lifted off because I was desoldering it so many times. So I start to ruin that board. I basically go into the point that I really cannot spend more time on trying to fix it, and that's go into the waste, into the recycle bin. So let's take a look at this unit and let's try to power it on. And as you can see, the inverter is working. We've got a green LED, we've got a 4 watts of idle power. When I grab the power plug from my lamp, it's nicely working, and as you can see, here is the lamp. I unplug it, I plug it here, the lamp is working. And if we measure the true RMS output voltage, so I stop the probes, as you can see, we've got a nicely 230 volts AC. So what I did, that this device is still working and I haven't thrown it away and it looks still good. And let's take a look what kind of magic I did. So what kind of scam did I pull? If you take a look, this is our panel that we are manipulating. We've got the input, we've got 12 volt output USB, and the AC socket with a AC inverter switch. We press that button and the inverter is starting. But if we take a look at the back, and I'm going to give you a better look in a moment, we do not have the inverter on that board. This is just a logic. The inverter is located here. And what I did, what kind of scam did I pull? I put a completely different inverter. I put different inverter, cheap Chinese inverter, like a 200 watts. So I'm ashamed of doing repair like that, but I didn't give up and I make this device fully operational. All functions are working. So I'm going to pull out the inverter that I put, and you will be able to see everything I did. You will be able to see everything. Let me unplug the fans. Here are fans. I just unplug them. They are connected here, and they are being driven from the logic board. Let's together take a look what's going on. It might look scary, but if you stay with me, you will understand absolutely everything and you will be able to make a good repair in future. Those are the main battery terminals. They go into the battery. They provide a power in and out. When we press that AC inverter button, what we are actually doing, we are turning on those two MOSFETs and they are feeding 12 volts from the battery into the inverter board. There is absolutely no other logic in turning the inverter on or off. We provide 12 volts, the inverter is starting. It was that inverter, here is the fuse, and there was a main voltage input. So I just connect my inverter. It was taller, as you can see. I grab a saw and I just cut it so it nicely fit. The current is going through those wires and it go into that car fuse. On that board, that was the fuse located here. And after fuse, we've got a small wire. That small wire is detecting whether the fuse is being blown. So the microcontroller is doing a simple logic. Do we have a voltage on those lines turned on? If yes, and we did not detect it on that sense wire, that means the fuse is blown. Very simple logic. I soldered it back and detecting of the fuse is working. If I pull the fuse out, it's going to nicely indicate that is being blown and need to be replaced. AC output go from that H bridge located here. On that part of the inverter there was a regular AC French style socket. So I remove that, I grab the wires and they are being routed into that section. That section have a opto isolator here and it is detecting whether the inverter is working and creating a correct voltage, and you can see that by a small exclamation mark between the start up of the inverter. So it knows that it's being turned on, but it do not have a correct voltage, so it's going to show the problem, but after a couple seconds it go away and indicate that everything is working nice. I've decided to put the thermal probe onto the low voltage side because there will be a much higher current, so there will be more losses. On the high voltage side there should be no problem. That wire is shorted and it was just a on-off switch. I've got it in a constantly on mode. I cut the enclosure to get dimensions that are exactly fitting into the genuine heatsink. So the idea is that it go like this and it's being snug fit next to the heatsink, and it should remove some of the heat into the real heatsink, and if it detects the overheat by that probe, it should turn on the fan and blow nicely by those both open ends. So to conclude that, I am not proud of it, but at the same time we were thinking out of box and we managed to fix this device. We restore a 100% of its features. So I believe we've got a good job. Let me put everything back and let's see how it presents after we've got every single part connected as it should be. As you can see, we've got a nice snug fit and it's lying against the heatsink, so it not only looks good, but it provides a heat dissipation. Let's see, does it fit nicely? Just take a look, it locks itself perfectly. We've got the heatsink, it looks like the genuine one. So everything looks good. We've got the 3 negative wires here, 3 negative on that side. As soon as I'm going to find the missing bracket that was holding the battery in place, I'm going to put it, but for sake of today's video, I'm going to put it as is. I'm going to nicely throw it in. I'm going to nicely go on the corners. And this is our goal 0. As you can see, you cannot see the sketchy thing that I did. We power the AC, we've got the exclamation mark, we've got a problem, the inverter started, it's detecting voltage, and it's showing no problem. We see the idle voltage, and let's once again plug our lamp, and the lamp is working. So as you can see, the goal 0 is working, the goal 0 is looking nice, everything is working like it should be. We've got the broken inverter in my hand and the device looks like the genuine. So in my opinion, we've got a good fix. I absolutely do not get the 300 watts. I'm going to correct that with a label printed on my Dymo, but it is good enough to make me happy. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.